Welcome back, everybody. Okay, so we're supposed to use the horizontal line test to determine if a function is one-to-one. So we've used the vertical line test to see if a relation even is a function. So right there, yeah, wait, that's the same color. We're close enough. Let me change that up. So yeah, I cannot find a vertical line that hits this one more than once. Therefore, it is a function. Same thing here. It's a function. In fact, they're all functions because it says, well, they are. All right, so now we're going to do the same thing, but with the horizontal line test. So for example, on this one here, every horizontal line I draw will hit the function no more than once. Okay, therefore, it is one-to-one. How about this guy? Well, that doesn't hit it more than once, but I can find a horizontal line that hits it more than once. So no, not a one-to-one function. Still a function, but not one-to-one. So how about this one here? Well, can you find a horizontal line that hits it more than once? The only chance is the x-axis, but this open circle right here is, well, there's no point there on the function. Therefore, this horizontal line I drew does not hit it more than once, therefore it is one-to-one. And this is a yes. This obviously is a no. Just look at the x-axis. That horizontal line hits it more than once. And then this guy here. Yeah, I can find a horizontal line that hits it more than once. Hey, I can find another one that hits it more than once. I only need one, but hey, I found two. So the answer is going to be no. And that's kind of how that works. So the idea of a one-to-one function is every x value has exactly one y value, and every y value has exactly one x value. So there's a one-to-one relationship between x and y values. Okay, so now let's get into it a little bit more. So we got these one-to-one functions, and they give us 3 questions down here. Answer these questions 3. Now, it says, what's g inverse of -2? Well, what the heck is inverse? Well, inverse means the opposite of a function. So for example, if f of x is 2 times x, this function doubles things. So its inverse function would do the opposite of doubling. It would chop things in half. That's the idea. Okay. And we label the inverse function with that little -1 there. There's a reason for it. I'm not going to get into it right now, but there is a legitimate reason for it. Okay. So now, if we had something like g of -2, we would say, oh yeah, this means when x is -2, what's y? Well, when x is -2, y is 7. And the answer would be 7. However, comma, this doesn't say g of -2. It says g inverse of -2. So it's going to do the opposite. All right. When you go from a function to its inverse, all x and y information swaps. So in this case, what that means is this says, hey, when y is -2, what's x? Well, when y is -2, x is 3. All right. And that would be the answer to that one. Or you could say, you know what, I'm just going to write out the entire relation for the inverse function. And it would just be everything swapped. So the first point becomes 7, -2. All x and y information switches on the inverse whenever you use the inverse of any function. So I swap all the x's and y's. And I don't have to do it like this for this problem, but I think, maybe it helps you to understand just a little easier what's going on. So that would be the inverse function. Okay, now, so if I was trying to solve the first one using the inverse information directly, then I could say, all right, go from -2 to 3, and then that's my answer. Okay. All right. What about h inverse of x? All right. So that means now it's not saying plug a number, and it's saying just go find the other function. Remember the 2x and the x over 2 a minute ago? Yeah, that kind of thing. Except this time, well, this function, there's a little more going on. We're not doing one thing to x. We are subtracting 13 and dividing by 7. Well, the inverse function should do the opposite. So whereas the original function has a minus 13, the inverse function should have a plus 13. And whereas the original function has divide by 7, oh, that means that the inverse should have multiplied by 7. But is that the inverse? Or maybe is this the inverse? I don't know. Maybe there's something else, but I think it's one of those two, but I don't know which one. So we got to go find out. And so here's how we do it. We take the original function, y equals x minus 13 over 7. And because we're looking for the inverse function, we swap all x and y information. So we swap the x's and the y's. And then we do what we always do, solve for y. So I'll multiply by 7. And then I will add 13. And then I declare that to be the inverse. So 7x plus 13. So it was one of them. Okay. That would be the inverse function. It will do the opposite. Okay. Now, I want to show you something here in just a second. Okay, so let's double check we've got the right function there. Okay, so I'm going to plug in the original function. I'm going to plug in its inverse into my calculator. Right. So there is the original function, and there is what I believe is the inverse. Okay, and I am going to go to the table. You can kind of do this on the graph, but I think it's easier on the table to know for sure if you really do have it. And so remember, in y1, that's where I plugged in the original function. Okay, so these are the y coordinates that go with the x coordinates for the original. And then in y2, that's where I put the inverse function. All right, so I could say, hey, look at this. For the inverse function, I'm just looking for things that aren't fractions or decimals. When x is -3, y is -8. So I know that -3, well, that is hard to see if you're colorblind. -3, -8, that's a point on the inverse function, which means if we flip-flop that around, -8 comma -3 should be a point on the inverse. So let's go to -8 for x, and yep, -3 right there. It's like it's supposed to be. Okay, so that lets us know, yeah, we got the right inverse. If you're, you may want to check a second point, just to make sure. Let's see, we've got -1, -2 is a point on the original function, which means -2, -1 should be a point on the inverse, and so it is. So yeah, we definitely have the inverse function, and that is a really nice, easy way to check. All right, now we still have this guy down here. Okay, so what does that mean? Because it's written kind of weird. It means h of h inverse, I kind of wrote that badly, of -3. That's all it means. It's just a different notation. It's not a big deal. All right, so h inverse of -3 says, all right, well, go to the h inverse function, which was 7x plus 13. Okay, and I'll plug in -3 into that function. And then that gives me, and this h on the outside, I still haven't done anything with it, and I'm not going to until for a couple of moments here. Okay, so it'd be -21 plus 13 is what, like -8 or something? Okay, now I've simplified what's inside, so now I can say, all right, what is h of -8? So now I go to the h function and I plug in -8. that correctly? Yeah, I think so. Okay. And that would be negative, whoops, negative 21 over 7, so negative 3. Hey, wait a minute, that's what we started with. And that makes sense, okay? Because remember, when you consider a function and its inverse, they do the exact opposite of each other. They undo each other. Whatever one does, the other undoes it. So basically, it's kind of like saying, hey, I've got this negative 3 here, and I'm gonna, let me change my color here. And I'm going to do some stuff to it called H inverse. So I do all that, and I end up with negative 8. Okay, and then I say, hey, now I'm going to take that and I'm going to undo it with the H, the opposite of H inverse, and I'm going to undo it and end up with what I started with. So if I don't even tell you what the function is, if I say, I don't sound like I was going to swear, what the function? If I just say, hey, Q of Q inverse of 9, and you don't even know what the Q function is, well, you know the answer is 9 because these guys are going to cancel each other out. You know, just like when you say, hey, x squared equals 16, take the square root. Well, square root and squaring, they're opposites. They cancel each other. They're inverse functions of each other. Or you could say j inverse of j of 2. They're opposites. They cancel each other out. You end up with 2. That's how it works. Okay, so on this one, they give us a function, hallelujah, and they say, find the inverse. Okay, well, I can do that. So the function is y equals square root of 5x minus 10. And to find the inverse, we want to find the function where the x and y are swapped. So we swap the x and y. And then we solve for y. So I square both sides, add 10, and then divide by 5. And then I plant my flag and declare victory, saying this really is the inverse function. Okay. Okie doke. So now we've done all the main stuff, but we also need to find the domain of this inverse function. Okay. Now remember, we're talking about the domain. That's the set of all numbers we're allowed to plug in for. Plug in for x into the y inverse function, or the f inverse function. But the domain of this is directly related to something about the original function. I guess that right there. Okay, and here's the relationship. Because remember, when you consider a function its inverse, all x and y information switches. Well, this is x information from the original function, which means, and you know, as the domain, which means that is the range of the inverse function. Okay, so this would be the range over here, but they didn't ask us to find the range, but you know, eventually they probably will. They want us to find the domain. Well, whatever the original function's range is, that becomes the domain of the inverse. So let's go find the range. And a nice way to do it is to graph the original function, and you know, look at what the range is. So we'll go boom, boom, and it's kind of messy. I'm going to fix that a little bit here in a second. Okay, so we got that, and it's a little better now. And so, what was that original function? I forgot now. 5x minus 10. Okay, so 5x minus 10. Okay, so if we look at the graph of it, you can say, oh, okay, so what is the range of this guy? What are the y values being used? Well, it looks like it's starting at a height of about half, but I think it's just getting really steep and it actually makes it to the x-axis. I think it actually makes it down to height 0 about when x is 2. So let's kind of check that out. I'm going to go to the table to double check. And when x is 2, yep, when x is 2, y is 0. Okay, so it looks like the y values being used are 0 and bigger. And that bears out on the graph as well. So that would be the range of the original function. Therefore, that would be the domain of the inverse would be everything from 0 on up. And that's how we do it. All right. Once again, find the inverse. Okay. This time we're just finding the inverse. That's it. Different kind of a function, but the idea is the same. Swap the x and the y and solve for y. Okay. Now, just to remind you of how inverses work, remember the original function has a cube root in it, and the opposite of that is cubed. So we know we're going to have to cube x at some point. The original function has a subtract 8, so the original function is going to have a plus 8 in there. All right, and the original function has a plus 9. So the other one's the inverse is gonna have a minus 9. Now, in what order we combine those three things, I don't know. Maybe it'll be like that. I doubt it. Maybe it'll be like that. We still have all those same puzzle pieces, just put together in a different order. Or maybe, I don't know, it'll be like that. I don't know. Let's find out. So the original function, y equals cube root of x minus 8 plus 9. So I'm going to swap the x and the y and then solve for y. So I'll start by subtracting 9, cubing both sides, and then adding 8. And then saying, behold, this is the inverse. Oh, I didn't add the 8. There we go. Oh, it was my third guess. I thought it was the second one actually, but I wasn't real sure. And then you can plug in the original, plug in your final, and check them out on the table. See which ones play out like we did earlier on the calculator. All right, here we go. A word problem. How fun is that? So scientists have found a relationship between the temperature and the height above a distant planet's surface. So the function is t of h. So it relates temperature and height, t and h. And so it's read t of h, just like any old function. And that means, just to remind you, that the temperature is dependent on the height. Okay. And, that's how it is on Earth. What's the temperature? Well, there's a lot of things that go into that, but part of that is your height above sea level. Okay. And then that helps to determine the temperature. Okay. C is the temperature in Celsius at a height of h kilometers above the planet's surface. The relationship is as follows. Oh, that's pretty easy. Okay, no big deal there. So let T inverse be the inverse function of T. Wow, what a surprise. Take X to be an output of the function T, that is X equals T of H, and H equals T inverse of X. All right, whatever. Okay, which statement best describes T inverse of X? Well, first of all, we need to make sure we can see all the statements. Okay, there they are, all 4 of them. All right, so let's think about this. The original, whoops, I gotta turn that on again. The original function, for that function, you plug in a height, and what gets spit out is a temperature. Okay, that's how it works. Now, that means that for the inverse function, okay, that means that you plug in a temperature, because everything's the opposite for the inverse function, and it spits out a height. That's what that means. Okay. Everything, all the X and Y information goes opposite. All righty. So they're saying, all right, what's going on with T inverse of X? Well, they say that X is equal to T of H with the original function. Well, T of H is a temperature based on height. So X is a temperature at some height, but it's a temperature. Okay. So over here, we've got in the T inverse function, that means we're plugging a temperature in. Hey, that's what we figured out before. Cool. And then what gets spit out of that? Well, if you plug in a temperature, you spit out a height, which we had already determined. And so the only one of these four that's going to make sense is going to be the first one. Okay, because this statement here is telling us, is giving us the height above the surface when the temperature is X. And we just said that X represents temperature. So you plug in a temperature of X, and then it spits out a height. That's how that one works. All right, so what is T inverse of X? All they're saying there is go find the inverse function. So if our original function is y equal, well, I'll say t, I guess. T equals 48.5 minus 2.5 h's. And then we swap the variables. Now solve for t. So subtract 48.5. Yeah. And whoops, let's keep it the same. And then divide both sides by negative 2.5. Then there's our answer for part B. Okay. Then it says, hey, go find T of 33, or I'm sorry, T inverse of 33. Oh, well, that's no big deal. So that just says, take the T inverse function and plug 33 in for the independent variable. Okay, I know it says hey, H, but it represents temperature in that inverse function, like we said before. Okay, so T inverse of 33 is going to be 33 minus 48.5 over negative 2.5. And let's see, that would be 15.5. Look at my calculator. Okay, and we get 6.2. 6.2 what? Well, remember, we plugged in a temperature, and so it's spitting out a height measured in kilometers, it says. Yeah, kilometers. So 6.2 kilometers up above the surface of whichever planet they're talking about corresponds to a temperature of 33 degrees Celsius.